So you found out Q1 and Q2, and to find out Q3, you know that Q3 is third vector is not given to you. So, but you know that Q3 is orthogonal to Q1 and Q2, and their Q is an orthonormal matrix. So Q3 length of Q3 is 1. So make use of that equation as in the previous problem. That is Q3 orthogonal, Q3 is orthogonal to Q1, so it is 0. Q3 orthogonal to Q2, and Q3 is equals to 1. From all the three, you will be getting equations, one equation from this, one equation from this. Solve that, you will be getting one variable in terms of other. You can find out x and y in terms of z, or y and that is z, y and z in terms of x anything. Just solve the equations this and this. And this equation is, you don't have three equations and three unknowns, so that you can calculate in calculators. You have only two equations and two unknowns. So find the two, just manipulate these two equations, and then Q3, why it is Q3 is x square plus y square plus z square equals to 1. It is square. So you cannot solve directly into the calculator. So make use of equation 1 from equation, from condition 1 we are getting equation 1, from condition 2 we are getting equation 2, and using those two equations you find out one variable in terms of the other two. So you have equation 2 minus 1, I am getting 1 x equals to y minus 4z, and equation 1 plus 2 I am getting 3x plus 3y equals to 0. So from this what I will get, from the second expression I am getting x equals to minus y. If I substitute it in this expression, x equals to minus y, what I will be getting, x equals to minus y. From this I will be get x equals to minus y, or y equals to minus x, and that is, if I substitute here I will be getting it as 2z. So x as here, x, if I am substituting it as minus y, and the other minus comes here, minus y, that is equals to minus 4z. So minus and minus get cancelled. This is 2y equals to 4z. So y is equals to 2z. So substitute in the expression x square plus y square plus z square equals to 1. So you know x in terms of z, you know y in terms of z. So you get the z value, and from that z value you get your x and y value. So you get your Q3 vector, that is x1, x2, x3, and you have to solve. Next is what is asked. So this is orthogonal to Q1 and Q2. What is asked? To solve Ax equals to B. So when if B is 1, 2, 7. So you have your Q1 and Q2, right? So you have your this one Q1 and Q2, and here x1 and x2, and here 1, 2, 7 is given. Solving the least square method. So this is your A. So I'll not solve it. You can solve it using A, or you can even solve it using the, yes, you had with 1 minus 2, 1 minus 4, it is A. So you can solve it using A, or even you can solve it using Q also. So here we are solving it using the A. So we have A transpose A inverse, A transpose B. So because the A value of A is not orthonormal, it is not equal to 2, you are making use of this equation. So I have A transpose and A, and I will find the inverse of that, and A transpose and B. Just multiply these two, I'll be getting this. Multiply these two, I'll be getting this. You can find, it is a square matrix. You can directly find the inverse in your calculator, or you know the methods of finding out inverse. So you can do that. Just here one more method. So two are different methods I use for finding out inverse. One is writing this expression and writing the identity matrix here, and just go on manipulating this matrix to become 1, or you can just, if it is a square matrix, just keep the diagonal values and change this with the values of minus 9 and multiply it minus 1, it becomes 9 and 9, and take the determinant. This is the determinant value. So if I take that 9 by 81, so here I am getting 81, I am taking 9 outside of this, so I have 1, 1, 1, 2. So I'll be having it as 1 by 9. If it doesn't strike to your mind, you can just take 1 by 81 and keep this 9, 9, 9, 81. So you have the simplified value, which 2 and 5. So the values 2 and 5 is your solution, right? The x cap, the nearer value x cap is equal to 2 and 5. You can check even the error vector if you want. So next is the next problem. Moving on to the next problem, if the vectors q1, q2, 3 are orthogonal, what combinations of q1 and q2 is closest to q3? So you have to find out the error. Here what we have done is, let us assume that q1 is nearer to q3 by alpha times and q2 is nearer to q3 by beta times. So squaring that, I should get an minimum error. So alpha q1 plus beta q2 minus q3. This is how many times it is closest to q1 and q2. So I have taken alpha q1 and beta q2. So squaring, that means what? Square is A transpose A, right? This gives you the length of the matrix. So this is the length of the matrix. So this is an error from x2, x3. If they are not deviated, you get it as this minus this equals to 0. If they are deviated, by how much time? Alpha plus beta I am taking. So the first transpose for a square, I have transpose of this expression and the vector itself. So just expand that, alpha q1 transpose, beta q2 transpose and q3 transpose. So it will be alpha is a constant, so you'll have transpose to q1 transpose, q2 transpose, and as it is. So you have what? You have this expression. From this expression, you have q1 transpose, and if I expand that, q1 transpose, and q2 transpose, and this will be left out. Another, that is q1 and q2 transpose gives you 0, and q2 transpose q1 gives you 0, and here also q1 transpose with q3 gives you 0. Because they are orthogonal, so that gives you 0. Only when Q1 gives you the length of Q1, Q2 gives you the length of Q1, and Q3 transpose gives you the length 1. So this is also 1, this is also 1. So what you have, error square is alpha square plus beta square plus 1. So what should be the error, minimum error? Minimum E square should be, that is, it should be equals to error, if I equate it to 0, we will have it as alpha square minimum error, that is constant is 1. So the minimum error will be 1. So 1 minus 1, that gives you 0, alpha square plus beta square. If I differentiate this with something, I'll be getting it. These are constant, alpha square beta square. Here I'll be having the minimum value, the constant value is 1. So alpha equals to beta equals to 0. So I have alpha square plus beta square equals to 0. When it is a square, what should be the values of alpha and beta? It should be equals to 0, not alpha equals to minus beta. Don't take it like that. So this is the problem. So I have given you some of the assignments. So you can try to solve these assignments depending on what you have understood from the videos. If you have any doubts, you can contact me. Okay? Thank you. So this completes your module 4 of linear algebra. So we'll move on to the next video. We'll move on to module 5. So do well. Thank you.